Now in this video we're going to show you a second method of simplifying these radical expressions. And this one, instead of using perfect square factors, we're going to be using what's called a prime factorization of the number underneath. And just a quick review of the prime numbers. Prime number is any number larger than 1, any integer larger than 1, whose only factors are 1 and itself. So examples of prime numbers, and the first several prime numbers are 2, 3, and 2 is actually the only even prime number. So 4, 6, 8, none of those are prime numbers. We have 5 and 7. 9 is not a prime number because 3 is a factor of 9. 11, 13, 15 is not, but 17 is, 19 is, 21 is not, 23 is, 29 is, and generally you will not need any bigger numbers than those for these types of problems. And the method I like to use for this I call upside down division. You might have used factor trees for these before, but we're just going to do upside down division to these numbers underneath. So we're going to do 40 first. So what I do is start with the 40, and what I do with this is I start with the smaller prime number and work my way up. So if a number is even, I keep dividing by 2 until it's no longer even. So we got 20, 2 goes into 40 20 times, still even. So 2 goes into 20 10 times, still even. So 2 goes into 10 5 times. And I keep going until I get a 1 here. So then prime number that goes into 5 is 5. And 5 goes into 5 once. Now, so then once I have all my prime factors lined up there, and what I do is I look for 2 of them. Okay? I have 2 2's here. So that is the number that goes outside. So we have 2 2's. And then I look for numbers that are left over that aren't a part of pairs. Well, I have 2 of them. I have a 2 and a 5. And what I do with those 2 numbers is I multiply them. So 2 times 5 is 10. So that's what's left underneath. So square root of 40 simplifies to 2 square root of 10, which is the answer we got in the previous video. Now doing the same thing to the square root of 12. And I'm able to change pen color here. So now that we've got 12, and again we're going to do the same thing. 12 is even, so I'm just going to keep dividing by 2 until it's no longer even. 2 goes into 12 6 times, still even, so 2 goes into 6 3 times, and 3 goes into 3 once, and I keep going until I hit 1, and then I look for a pair of something. So I've got a pair of 2, so that's going to go outside. And what's left over that's not a part of pairs goes inside, which in this case is just 3. So 2 square root of 3. So now doing the same thing with 80. We start with 80, we're going to do upside down division to 80. So it's even, so 2 goes into 80 40 times. Still even, so 2 goes into 40 20 times. Still even, 2 goes into 20 10 times. This is still even, so 2 goes into 10 5 times. No longer even, but a prime number that goes into 5 is 5. And that goes in once. So now I'm looking for pairs again. And I've got a pair of 2's here and a pair of 2's here. So I would bring a 2 outside for this pair and another 2 outside for this pair. So what I do with those two 2's is I multiply them together. So 2 times 2 is 4 on the outside. And what's left inside are all those numbers that are not a part of a pairs. Well, the only one that I have left over is 5. So it's 4 square root of 5. Now, other people, unlike me, where I just keep dividing by 2 till it's no longer even, some people actually prefer to knock down the number smaller a little bit quicker. So they see that this ends in 0, so they know that that is divisible by 5. So they'll divide that by 5. And it goes in 16 times. And the prime number that goes into 16 is 2, 8 times. 2 goes into 8 4 times. 2 is into 2 2 times. 2 and 1. Now, one thing you'll notice is that even when I divided by 5 first, I still ended up with a 5 and 4 2's on the outside, just like we did over here. So you get the same answer. Some people prefer to knock it down to a smaller number quicker, so they would have divided by 5 first. Same thing here with the 40. Okay, so that is something that could also work, but you'll end up with the same numbers. But one thing to be careful of, make sure you're always dividing by prime numbers, one of these prime numbers. So now, finally with 288, this is going to involve quite a bit more division with the 288. And since this is even, I'm just going to keep dividing by 2 until it's no longer even. So this is 144. 2 goes into 144 72 times. Still even, so 2 goes into 72 36 times. Still even, so 2 goes into 36 18 times. 2 goes into 18 9 times. No longer even, but 3 goes into 9 3 times. And 3 goes into 3 once. So then I'm looking for all of the pairs. I have a pair of 3's, a pair of 2's, and another pair of 2's. So what do I bring outside for each of those pairs? For this pair I bring out a 2. For this pair I bring out another 2. And for this pair I bring out a 3. And I multiply those. 2 times 2 times 3 is 12. And then what's left over inside is the number that's not a part of a pair. Okay? So that is the prime factorization method for solving or for simplifying these radical expressions. You choose whichever method works best for you. Personally, especially for these larger ones, I prefer the upside down division method with the prime factorization. That way you're ensuring that you find that largest perfect square that goes into it, and you're simplifying it as far as it can go. So tomorrow in class we're just going to practice simplifying these radical expressions before we start solving quadratic equations that have these irrational solutions.